Welcome to the session on vectors. In this unit, we will be looking at the magnitude and direction of vectors. The objectives for this session are to calculate the magnitude and direction of a vector. A vector has both magnitude and direction. You can use Pythagoras' theorem to calculate the magnitude of a vector. So, for a vector A equals xi plus yj, or as a vector written as x, y, we can illustrate this as shown. So here's the x part of A, and here's the y part of A, and this becomes a right-angled triangle as shown. The magnitude of a vector is mod A equals the square root of x squared plus y squared. A unit vector in the direction of A is A hat equals A over mod A. Let's now take a look at some notation. Use straight lines on either side of the vector. So mod A means the length of A, or mod xi plus yj, which equals mod of the vector A. Let's take a look at an example. If mod A equals 7, then A hat is equal to A over mod A, which equals A over 7. And it can be illustrated as shown. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at example 2a first. Given that the vector A equals 3i plus 2j and the vector B equals minus 2i minus 7j, find mod A. So let's solve this. Mod A equals the square root of 3 squared plus 2 squared, which equals the square root of 13. And of course here we've used Pythagoras' theorem. And now for part B. Find A hat. So let's solve this. From part A we have that mod A equals root 13. And therefore A hat from the definition of a unit vector is equal to A over mod A. And simply plugging in the values gives us A, which is 3i plus 2j, over root 13, which is mod A. And this is our unit vector. And now for part C, we are required to find mod 2a plus b. So let's solve this. 2a plus b is as shown. So here's 2a and here's b. Let's expand the 2a, which becomes 6i plus 4j as shown, and leave the b as it is. Then we collect together the I terms, so 6i minus 2i equals 4i, and we collect together the j terms, so 4j minus 7j equals minus 3j. Now 2a plus b therefore equals 4i minus 3j, and therefore mod 2a plus b equals the square root of 4 squared plus minus 3 squared, which equals 5. So here's a summary of our solutions. Let's now introduce a definition. A vector can be defined by giving its magnitude and the angle between the vector and one of the coordinate axes. This is called magnitude direction form. Note that the measure of a positive angle theta is anti-clockwise from the positive x-axis. Let's take a look at an example. Find the angle between the vector 2i plus 5j and the positive x-axis. Here are the axes x and y. Here's the vector 2i plus 5j. Here's 2 and here's 5, the lengths in the x and y directions. And here's the angle theta. From our tan ratio, we know that tan theta equals opposite over adjacent. So if this is theta, then the opposite is 5 and the adjacent is 2. So tan theta equals 5 over 2. If we inverse tan 2.5, we obtain that theta equals 68.2 degrees. And now for example 4, we are required to write the vector shown in the diagram in ij column vector form. Now the angle theta is equal to 90 degrees minus 40 degrees, which equals 50 degrees. And cos theta, from the formula adjacent over hypotenuse, is equal to x over 11. So therefore x is equal to 11 cos 50. And on our calculator this gives us that x is equal to 7.1. We also have that sine theta from the sine ratio is equal to opposite over hypotenuse. So sine theta is equal to y over 11. Therefore, y equals 11 sine 50 degrees. And plugging in the values in our calculator gives us that y equals 8.4. So to summarize, we have that x is equal to 7.1 and y is equal to 8.4. So the vector is 7.1i plus 8.4j. This brings us to the end of this session. If you have understood its contents, you should be able to calculate the magnitude and direction of a vector. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.